Good morning, good afternoon, good evening. Welcome to C Programming. And I believe you've already considered week 1, week 2, and this is our week 3. If you are accessing this video on YouTube, this is a course taught on coolcharts.com. So you could visit coolcharts.com to access the course content. So as you already know, or if this is the first time, I normally use the course content on the website to prepare the video. So it will be nicer or easier for you if you visit the website so that you can easily copy and paste the code and do some modification instead of you typing from scratch. So you are warmly welcome if this is your first time. And if you've been on the course for week 1 and week 2, then week 2 we considered how to declare variable, and we said we declare variable to reserve a space on the memory so that when we take a value from the user, or if we manipulate the data and we want to put it on the memory, then we can put it over there. So if you don't declare a variable and you are trying to assign a value or put the data in that memory, you will get syntax error. Okay, so we give names to the memory allocation where we want to put the information. So that's what we call a variable declaration. Then we also saw some rules of declaring variables, that you can't leave a space between the variables, and you cannot start variable name with a digit, and the variable name should not have special characters. So that's basically what we did. Then we also saw how to get input from the user. We considered 2 functions. We considered a printf, which displays information on the screen, and we also considered a scanf, which takes input from the user. Then we saw the basic syntax for scanf. So I believe you practice some of these way of getting input from the user as we did last week. So this week, what are we going to learn? We are going to do the arithmetic expression. So if you are doing programming for mathematics, what are some of the operators you need to use? So we'll look at the operation for addition. We'll also look at the operation for subtraction. Then we'll look for the operation for multiplication. Then we'll look for the operation for division. Then we look for operation for remainder. So the remainder is normally the modulus. So once we finish learning that, we will also take some few examples of code you can write with this concept or knowledge. Okay, then we also look at functions. So you also look at functions, how to write your own functions. So we look at how you can write your own functions, and also how to call functions of the one that comes with the compiler or the programming environment. So basically this is what we are going to learn. So I believe you've started your code block already. If not, then you can get your code block ready so that we can start coding. So I'm going to zoom the page so that you can see the codes clearer. So okay, so that is it. So the operator used for addition is the plus key. So on your keyboard you just press the plus. So if you have a variable name A and you have a variable name B, a variable name A means that you reserve a space on the memory and you've given it a name A. Then the variable name B means you reserve a space on the memory and you've given it a name B. And like the way we last week we learned that you need to declare the data type of your variable so that the compiler or the computer will know how much memory to reserve for that data. So when you are declaring a variable, you need to first of all specify the data type before, then you leave a space before the name of the variable, so the appropriate size on the memory will be allocated, so that when you get the information from the user, you can put it there, or when you manipulate the data and want to store it there, you can do that. So these are some examples. So addition is plus. So these are some examples. So we have int a is equal to 2. This means that we are reserving a space on the memory and we are giving it a name a, and it's of the data type int. Okay, so this space will be reserved on the memory. Then we say equal to mean assign. So it's like putting the value. So the value that comes to the right hand side will be placed on the memory by name a. So here is equal to 2 means that on the memory where we have the variable a, we assign the name a to it, place 2 over there. So equal to is assignment, or putting the value on the memory. So that's basically. Now you can declare the variables all at once. So you can have 2, 1, 2, 3, 4, 5, and so on, all at once. If you are declaring a variable more than once or one, then you need to separate them by comma. So each of the variable will be separated by comma. So like you can see, when we declare our int a is equal to 2, then since b is also int, we don't need to declare it int again. So we just leave a space. So comma a, we use comma, then the variable name, and we use the equal to assignment, then we'll assign the value to it. Okay, so now the next one is that we are using this operator, but we want to add the 2 variables, then put the result in another memory we are naming C. So C also means that this syntax means that create a space on the memory and it's of the type int. Then the equal to means assign what you have at the right. So what do we have at the right? So it says that add a to b, then assign, which we put it on the memory with name C. Then this printf, last week we saw printf means display. So now we are going to display the information on the screen. So last week, like we said, that we use placeholders for where we want a particular variable to be replaced by. So we use placeholders, and placeholder for the printf for int is %d. Then placeholder for float is %f. Then we also learned that double is lf, and so and c character is %c. So that's basically the placeholder. So when you write a placeholder in the printf, then after finishing everything in the bracket, you write a comma, then you indicate all the placeholders, the values or the variables that needs to replace them. So as you can see, we have 3 placeholders. We have 1, 2, 3. So you need to indicate all the placeholders, the variable names that is going to replace them. So our 1 will be replaced by a. So the value of a will come over here. We will place our placeholder here. Then we have our plus. Then our second placeholder will be replaced by our second value variable name b. So the value stored on the memory for b will be there. Then the value stored on c on the memory will also be on the last part. So here we know a to be 2. So we have 2. We know b to be 5. So we have 5. 2 plus 5 is equal to, then the result, it says add the 2. So we add 2 plus 5 is 7. So the result, which is 7, will be stored on our memory by name C. So if we are displaying the content of C, it's going to be 7. Okay, so this is an example. So I'm just going to use the operator here, explain the operators we'll be using. Then we can code with an example so that you can see what I'm talking about. Okay, so subtraction, we use the minus, just the minus key. So look for the minus key on your keyboard. So the minus key is just the dash one on your keyboard. So if you want to use do subtraction between two variable names or two variables, you just use the manuals, just like the way we know normally manuals. So you look for the manuals on your keyboard, then you press it. Now, if you want to do multiplication, we use the star, the asterisk, the star. Okay, so you look for the star key, the asterisk key. So that's what we use for multiplication. Always remember, it's not X that you type for multiplication. In programming, we use the star. So if you are going to multiply two variables, you have to use the star key. So you use the star, so you write the variable, then you press the star key, then the second variable, then they will be multiplied. Then to do division, we use a slash key. So you just use a slash key for division. Then to find the modulus is a remainder. So the remainder, we use percentage. So if you have two integers, a percentage between them, it means that you are finding the modulus of that number. So for example, if we have a int a, just like we have over here, okay, now b percentage a means that we are looking for the modulus of b. So it's 5 modulo 2. Our a is 2, so our b is 5, so this will be 5 modulo 2, and 5 modulo 2, we know the result. It's a remainder. So if you divide 5 by 2, 2 goes into 5 2 times, which is 4. So 2 times 2 is 4. Then we will be left with 1. So 5 modulus 2 is 1. Always the remainder is what you write. If the remainder is 0, the modulus is 0. If the remainder is 1, the modulus is 1. If the remainder is 2, the modulus is 2. If the remainder is 3, the modulus is 3. If the remainder is 4, the modulus is 4, and so on. So if you want to find the modulus of a number, we use this approach. Now, when we come to a conditional statement, in conditional statement, we use a modulus to check if a number is an even number or odd number. So we divide the number by, we find the modulus of that number by, or the modulus 2 of that number. So if you find the modulus 2 of that number, if there is a remainder, it means that it is not even. But if the remainder is 0, it means that number is even. So when we get to conditional statement, please remember that the modulus or remainder, we use a percentage. So you just press the percentage key. So once you press it, then that will be the modulus. So you can use it to find the modulus. So when we start to write a program to check if a number is even or not, we will call this modulo operator. So please remember when we get to that point. Okay, so addition is plus, subtraction is minus, multiplication is asterisk, then slash is division, then percentage modulus. This we do them in math, so you already know these two the same. But the new thing you are learning in the programming when it comes to multiplication is asterisk. So you pay attention to it. So when we are multiplying programming, we use the asterisk, the star. When we are dividing, we use the slash. When we are finding the modulus, we use the percentage. So now we are going to start our code block. Now once we are done with our code block, when we create a project for week 3, then we will take a practical example of this. Okay, so this time we are going to ask the user to enter 2 numbers. So the 2 numbers the user will enter, then you will find all these results. So we first of all add, we will subtract, we will multiply, we will divide. Okay, so when we do that, then we also do the modulus. So for this, that, and that, we will use double for all of them. Of course, we can use int, but I want us to use the same variable for the division, and that because the user is the one who's going to enter. If you define it int and the result you also make it int, it will cut the fraction part from it. But anyway, I will do everything int, then later on we'll change it to float so that when I run you can see what I'm talking about. So start your code block, as I'm also going to start my code block. Okay, so start a new project. So file, new project. So console application, then go, then next, then this is a C, so C, you choose C, then project name, this is our Victoria, so I'm going to name it Victoria. Okay, so remember to check where you are saving your project. Okay, so here I go back and save my project somewhere. I don't have C folder, so I'll create a C and I put my project there. So new C. Okay, so C. Okay. So that's where I'll be putting my project. So I save it there. Okay, so we create the folder is C. Okay, so next. So the compiler is this one. Then you click finish. Okay, so as you know, the code is in the sources. So you click on the main. So that's your default code. So in your default code, you just do the modification. Okay. I wanted to zoom it, but it's not zooming. How you zoom? It's not zooming. Okay. So it's not zooming, so let's. Okay, so what we are going to do, so we don't need the hello, so we are going to declare variables. This time we said we will allow the user to enter the value. So we have int a, b, c. Okay, then yeah. Okay, so we ask the user to enter the first number, we ask the user to enter the second number. So we store the first number in A, we store the second number in B, then we will do the operators on it and store them. So addition, we'll store it in C, division, we'll store it in addition, subtraction, multiplication, E, division, F, then G, modulus. Okay, so that's it. So we'll use it to reserve a space on the memory so that we can get the first number from the user, and this one we reserve a space on the memory, so we use it to store the second number we get from the user. Then the C, we use it to store the addition of the two numbers. Then the D, we use it to store the subtraction of those two numbers. Then G, we use it to store the multiplication of those two numbers. Then F, we use it to store the division of those two numbers. Then G, we use it to store the modulus of those two numbers. So as you know, the information cycle display information on the screen. You display the instruction to the user. So the instruction display, we said we use what? Printf. to display on the information. So that one, we have the output. Then we will now be expecting the user to enter something. So for the input, we use a scanf to get the input from the user. So that's basically what we'll be doing. We display, we give instruction on the screen using the printf, we get the value, then we do the operators on it, store the value, then we display it, then we move on to the next one. So in that way. Okay, so let's get started. So we need to first of all tell the user to enter a first number. Okay, so we are going to ask the user to enter first number. So you know what we use, printf. Okay, so in the printf, the bracket, we put our text inside. Okay, so printf displays information on the screen. So we write printf, it has brackets, the inside is a double quotation where we put our text inside. Then, like you know, all syntax should end in a semicolon. So please display on the screen, please enter, or if you don't want to be too polite, enter first integer. Okay, so we write integer so that the user will know that it's an integer it is expected to enter. So let's run it and see. Okay, okay, so that's it. Okay, enter first integer. Okay, so now we will get the value from the user. So we have scanf. We said the scanf, the placeholder comes here. So percentage, our memory data type where we will be storing the first number is integer. So what placeholder do we use? We said we use the D. So that's the placeholder. So percentage D is the placeholder for the integer value. So this is our placeholder. We've written it. Then comma. Then you have to use the end key. So you enter the end key so that it indicates the memory where you are going to put your distance. So you enter the end key. Okay, so after the end key is a variable name where you are storing your input value. Okay, so here the scanf here is a placeholder, then the end for the address, so end, then the variable name. So always remember, don't leave the end and then get a syntax error. So placeholder is an integer, so percentage D, then we have the end, then the variable name. So we separate them by comma. Okay, so this is for A, so we can copy and paste for that of B. Okay, so enter second integer. So here is that for that of B. Okay, so now we've printed on the screen, we've given instruction to the user to enter first integer. We've scanf, we've taken the value from the user. Now we've given second instruction for the user to enter the second integer. Then we scanf to take the second user and store it on the memory with name B. This one will store it on the memory with name A. Now we will add the 2 and store it on the memory C. So like we said, to store or to assign the value is the variable name, then equal to. Okay, then we have A plus B. Okay, so this the value stored in B will be added to the value stored in A, and the result, this is assignment, is like put in the memory. So this assignment, so the result will be put in the memory by name was C. So when we display the content of C, it's going to have the addition of A and B. Now, when we display the content of A, it's going to have the integer value the user entered the first time. When we display the content of B, it's supposed to have the second integer the user entered. Okay, so now we are going to display it. So we say printf is for display. Okay, so but remember this time we will use placeholders so that we know what we are doing. So the first value integer we got from the user will have this placeholder. Then we have our plus. Then our second integer we got to have the second placeholder. Then we have equal to. Okay, so the placeholder is a temporary the meaning of placeholder, something temporary which will be replaced by something. Okay, so that's basically what the placeholder is. So we are creating a space where the value of our first integer variable will be here. Then the value of our second integer value will be here. Then these are just tests. So that the user will know that if the user entered maybe 1, so it will and 2, then it will be 1 plus 2 is equal to. Okay, so our third one will be the placeholder for our C, so that we will display the content of A. The placeholder for our C, which is %D. So now, if you finish with the ones in the quotation and their placeholders, then you have to indicate the values which are going to replace your placeholders. So we have comma. Our first placeholder is supposed to be replaced by A. Our second placeholder is supposed to be replaced by B. And our third placeholder is supposed to be replaced by what? C. Then you end your command. Okay, so now if we run, so I go over then we run, so we can do the others as well. So we said the addition operator is plus, so as we've seen, so this will add this to this, and then the result will be stored on the memory C that we name. Okay, so the first, declare your variables. So like we said, the variable declaration creates a space on the memory where you will be putting your values. So to declare a variable, you need to specify the data type. So that's our data type. We are declaring all of them to be ints. So the int is for integers, so we declare that. Now in the information cycle, remember, if you want to output, you have to output something on the screen to give instructions. So that's the output. You need to get input, feed the computer with input. So that's the input side. Then once you manipulate everything, you will have to store it. Once you store it, you also have to display it again. Okay, so we have the outputs for displaying the instruction on the screen. Then we have the input for taking the keyboard input that the user will enter. Then we display again. Then we expect the user to enter something. So once the user enters, we take the value. Then we now manipulate the entered data. So we add our second value to our first value. Then the result, we save it in our memory space C. Now on the display, we want to write maybe this plus this is equal to that. Okay, so this is the placeholder for the first number. This is the placeholder for the second number, and this is the placeholder for the addition, which will be the result stored on C. So like I said, once you've written your placeholders, you need to indicate what variables are going to replace your placeholders. So the first placeholder will be replaced by the content of A. The second placeholder will be replaced by the content of B. And the third placeholder will be replaced by the content of C. Okay. So now let's run it. Okay, so enter. So I've entered 4. Enter second number, I've entered 2. Okay, so as you can see, it says 2 plus 4 is equal to this thing disappears for the reason again. So 2, 4. Okay, so now as you can see, 2 plus 4 is equal to 6. Okay, now let me put a comma here. So column, let me put column. Okay, so this one is just to make it a little bit presentable, so that I will be after the column. Okay, so now we move on to our subtraction. So instead for subtraction, we save it in D. So D is equal to let's say B minus C. Okay, so then we say E is equal to this E is for multiplication, right? So we can have B minus A. Then A is equal to A times B. Okay. Then F is equal to, let's say, B divided by A. Then G is equal to B modulus A. Okay. So now I'm going to display all of them. So you can display after that. So here, this one is subtraction. So you have our first letter is B. So our first placeholder will be B. Our second will be A. And our result is our D. So D. Okay. Then followed by this. So we have multiplication. So for multiplication, you can use for the test. Multiplication test, you can use the X. So we have this times this is equal to our first placeholder can be A, can be B. Then the result is stored in F. Okay. Is it F or E? E is stored in E. So then we display this one too. This is division. So here our first one is B. Our second one is A, and our result is F. Okay. Then we display this one. So this one modulus. Okay, so mod. So here our first number is B. We find the modulus of B. And our second one is our A. Then the result is stored in G. So we have G. Okay. So now we save everything. We run. Okay. Now I want my first letter to be 3. My second letter to be 4. Multivirus is disturbing. So 3. This adverse. What is it? So we have 4. We have 3. Okay. So we have 4 plus 3 is equal to 7. 3 minus 4 is equal to 1. Now, because we didn't start on a new line, it is making them all to be on one line. So now let's separate all of them by a new line, starting from, so it's all this one. So we start them from new line. So the next one will start from a new line. So for a new line, it is slash n. So the slash n will let it move to the new line after it has been displayed. Okay. So let's so 5. So if you don't know what separate is, this time I need to shut down this. So 3. Okay. So as you can see, 5 plus 3 is equal to 8. 3 minus 5 is equal to -2. 5 times 3 is equal to 15. 3 divided by 5. This is 0 point something. But because it's an integer, it's the fraction parts disappear. So 3 modulo 5, you see that it is giving 3 because the 5 cannot go into 3. So in the other practical example, we give the first number to be 3 and the second number to be 5. Okay. So 3 and 5. Okay. So we have 3 plus 5 is 8. 5 minus 3 is 2. Make it is 2 there. 3 times 5, 15. 3 divided by 5 divided by 3 is 1 point something, but the decimals will cut off because it's an integer. And 5 modulo 3 is equal to, because 3 goes into 5 once, so we have 2. Okay, so now if you want the fraction part to remain, then you have to do separate. Then you have to separate the fraction aspect. So for the fraction, for the division aspect, you can declare double value. So double maybe h, ABCD, EF, G, H, I, J. Okay. So we will use h to store the first double odd number. Then we use I to store the second number. Then we use J to store the division of them. Then we display. So I can copy here and I modify it. Okay, so before the division, this is the, okay, so over here. So enter first number. Okay, now this is a double, so it's going to be LF, the placeholder. Then we said that one is H. So enter second number. That second number is also double, so LF. Then our placeholder I. Okay, so now the division will be H, maybe I divided by H. Now since okay, so can make our F. So here we have F, H, and say I. Okay, so F, let's use F to take it. Then H, take the second one. Then I will be equal to maybe H over F. Okay. So now it's going to be our first one is going to be which one? The H is the one which is being divided by F. Okay. And the result we save it in I. Okay. So we have the second divided by the first, and the result is stored in H. Okay, then we have this over there. So build and run. Okay, so 3, that's a 4, 2. Okay, so 4 plus 2 is 6. 2 minus 4 is negative. Oh, avast. Why is disturbing? 4, 2. Close. Okay. So enter first number. So here we can enter this one because it's double, so it will show the fraction. Why is it showing 0, 0? What did I do? So that one in format or display, I'm using F. I'm using D for displaying this thing. So it's supposed to have since they are double, the placeholders are supposed to be F. Percentage F. For the print F, I think the double placeholder is F, not LF. It's only the scan F that the placeholder is LF. Let's have this thing. Okay, so 4, 2, then 5, then 3. Okay, so as you can see, since they are in double, you can see the decimal parts are there. So in the after the 0, we have the fraction aspect. If you use int, you saw that the fraction part was cut. Okay, so basically that's it. So look for a formula and write a function for them. So there are a number of scientific formulas. So you write a program that will ask the user to enter some scientific data. Then you write you code the formula. So for example, if you write a function to write a program to calculate the force of a body. So here you ask the user to enter the mass of the body. Then you ask the user to enter the acceleration due to gravity of the body. And we know force is equal to acceleration due to gravity times mass. So you multiply them, then you display the force to the user. Then you can also write that for converting degree to Fahrenheit. So you can also do that. Then you can also write that for kinetic energy, calculation of kinetic energy. So kinetic energy is equal to 1/2 times mass times velocity square. So remember, square is the multiplication of itself. So velocity will multiply velocity to so if you declare a variable v for velocity, then the square is going to v star v, which will take care of the square. Okay, so for practice, do all these things. So if you have any challenge, just post in the comments. And if you are able to do it, please don't share your code so that others will also try it themselves, and that you not motivate them to practice what they are learning. Okay, so if you are able to do that, then you'll be able to practice the operators we use for math: addition, subtraction, division, modulus, multiplication. Then you've also been able to display information on the screen. And you've also been able to use placeholders in the display to replace the appropriate values in the memory. So when you are using the placeholders, so you should also know the placeholders by heart. You should know that the placeholder for taking input from the user for in the stand F for double is LF. That of float is F. Then that of char is C. Then that of integer is D. So you just add a percentage to all of them. Then you have a comma where you give the memory address. So in the memory address, you use the end for the address. So you type end, then the name of the variable. So this will fetch. We'll put whatever you get from the user and put it at that memory address. So you get this from the user, then you put it. So the placeholder shows what you're supposed to be there. So once it's been taken from the user, it is stored on the memory. So when you are fetching it from the memory, you want to display to, so that one to use the placeholders. But you have to indicate in the order of the placeholder which variable names are supposed to replace your placeholders. Like I said, placeholders temporary will hold something. So when you get the actual value, it's replace it. So in the printf, you need to indicate in the order of the variables that are going to replace your placeholders. Then we use a /n for new line. So if you want a new line, you use a /n for a new line. Okay, so basically that is it for this part. Then we'll quickly talk about formatting values of type int. So to format values of type int is just in the display. If you are displaying and you want to space your integer values, you can use this method of formatting. So the formatting is how many columns are going to handle your placeholders. So for example, if you have %3 d, so in the integers you put the columns between your percentage placeholder. So the placeholder for integer we know is %d, so we only put 3 there so that it gives it 3 columns. So 3 columns, if it's 3 digits, 2 will be there and 1 will be empty. So this is an example. The same thing with 4. We are having 4 columns. So you have your 4 columns. So if you have your 4 columns and the digit is 2, there will be 2 more space left, empty space. Then the others will follow or continue. So this one also has 2 columns. Okay. So to give actual space for the digits, we use for the integers, you just put the number of columns you want between the placeholder for the d. So between the percentage and the d, you put the number of columns you want for that values of the placeholder. Okay, so basically that's it. Now formatting values of type double. So for type double, we use a general syntax. We use a general syntax. There was a syntax here. Okay. So we use this general syntax. So percentage. So you know by default the placeholder is percentage f. So this part is the one that you need to look at. So this is where n is number representing the total filled width. Okay, so like we have the column for the integer, so the filled width also we have our n in it. Then the m is our number of decimal places that we want. So if you want 2 decimal places, here it's going to dot 2. If you want 3 decimal places, it's going to dot 3. If you want 4 decimal places, it's going to dot 4. If you want 5 decimal places, it's going to dot 5, and so on. So this is for decimal places, and this is the width, the number of width you want, or the columns that you want. So that's it for formatting the type double. So we move on to functions. Okay, a function is a block of code which performs specific tasks. So as a programmer, you may write blocks of code to perform a particular function. For example, the addition that we can write a function that takes in 2 numbers, then it will add them and display or return the result of the 2 numbers. So that's a task. So every function has a task. So you, the programmer, based on the task you want to achieve or you want to perform, and the code you write inside. So you write your code in the function. So there are library functions. There are functions which has already been written for you in your programming environment. So each of the programming environments have their own functions which has already been used. So those ones, we call them predefined functions. You are not the one who wrote them. So they are already there for you. So you, the programmer, you have to know that those functions exist. Then you should know their name, and you should know how to call and use them. So that's basically you, the programmer. If you want to use a predefined functions, you have to know them and know how to call them and know the type of inputs they take or arguments they take. Okay, so in this is the part of a function. So in this example, we have the sqrt. Sqrt finds the square root of a number. So what the number, which is the argument, or I'll call it in the layman English, input. So the input you give to that function is what we have over here. So the inputs are placed in double quotation. If there will be more than one input, they are separated by commas. And the inputs also have data types. So in the function, they will specify the type of data which are going to be the input. So when you are passing those input values, you also pass the appropriate data types. So if a function has been declared to be an input, to receive an input of integer, then you pass in an input of double, you are going to get a syntax error. So a function has a name. Just like the way we name variables, a function has a name. So you have, like this, for example, you have sqrt. Okay, so now whenever you use a function in your code, we call it function call. So if you call or you call the function in your code, we call it function call. So basically this is it. So here in this example, it means that call the function sqrt, pass in this argument, then the result that you get for the square root, you assign it to the memory by name y. So anytime I want to display the value of y, I can do that. Anytime I want to access the value of y, I can do that, and so on. So that's basically what the function is about. So these are predefined functions, but some of these functions you need to include the header files in order for you to be able to call those functions. So if you want to use the absolute, you need the std.h. So you include it, then you can use the absolute. So the absolute returns the absolute value of its integer value. So absolute value is just the positive value of whatever you are finding is absolute. So if it's negative, it will be positive. If it's positive, it's still going to be positive. Okay, so we use the math.h. Then the cell retains the smallest integral value that is not less than s. So for example, if we have 4.45.23, so the cell is 46. So the cell will get the smallest value, nearest smallest value. Then we have the cosine, then we have the exponent, then we have the absolute value, which is for double, the other one is for int, then this one is for double, then we have the floor, then we have the logarithm. So if you want to find the logarithm of the number, then, but remember the other files to include. So this one sa.lib.h, this one math.h, math.h. To find the power of the power of a number, this is the base and this is the power. So 2 exponent 3 will be power POW, comma, then the base is 2, then comma, and then 3. So if you output or you assign this to a value, it will have the square of that, the power of that number to that base. Then this is for sine, and this is for square root, like you've seen, and this is for time. Okay. So exercise: create a project and name it with 3. Exercise 1: write a program that takes a number and output the square root of that number. So remember, here we need the function, the square root of the number. We need the function what? Where is square root? SQRT. That is the square root. So we need the math.h header file. Okay, so as you can see, we have the include, then less than math.h header file. So this one is what we use to get to call the SQRT. If you haven't included that header file and you are running, you get a syntax error. Okay, so I will go through this code with you. So, but you can also try to write it. So we have it declares and two numbers, double number and roots. So the number takes the number, then the root, we find a square root and assign it to root. So we like below, printf displays the information on the screen. Then since the data type is double, now because it's square root, it can be double or int. But if you want to accept fractions in your square root, then it's better you declare it as double. So we have this one gives the instruction to the user to enter a number. Then we've declared our number to be double, so we need to use a scanf with a placeholder lf. Then we have the end, then the variable name. Then we call the function sqrt, which takes in the argument. So it takes in this argument, then it finds the square roots. Then the assignments, you put the results in this memory, which we've also declared as double. So once it is in the memory, we can display the information. So we write the square root of, okay, so the square root of, so the number is what we have there. So that's the first placement. It's supposed to be placed by the number. Then it's supposed to be placed by the root. Okay, so the square root of then percentage f is percentage f. Then we indicate in the order of our placeholders what needs to replace it. So the first placeholder is supposed to be number, and the second placeholder is supposed to be root. So like I said, you need to include the math.h before you be able to run the code, and that you get a syntax error. So because the header file, this include math.h has the header file with that function already written inside. So when you include it, it imports those functions into your project so that you can use them. Then finally, we are on user-defined functions. So user-defined functions are functions you yourself define them. So functions you yourself define are called user-defined functions. So it's the same way we have the predefined function. That one, you give the function a name. Just like the same way we name variables, it follows the same rules. You can't start with an integer or a number. You cannot leave a space between them. You can't use special characters and so on. So the same thing. So this is a basic syntax of a function. A function, you need to declare the data type, whether it's going to return an integer value, whether it's going to return a float, whether it's going to return a double, whether it's not going to return anything at all. So you have to declare the data type. Then you give the function a name. So this function, you give it a name. Then we have the function input, which we call the argument. So if you also specify the data type of your input, and if you are going to use more than one input, you separate all of them by commas. So you write the data type, then you give the data a name, then comma, then the data type, then comma, and so on, based on the number of inputs you want to have from that function. So if the data type is int, the function must have to return a value of the data type int. So if your data type here is int, what you return here should be int. So like I explained you from the week 1 that we have to have return 0 here because of this function int main. So the main is a function. So this int main is a function which is of the data type int. So you need to return at the end, you need to return an integer value. So 0 is an integer value. So this function is okay. So that's it. Then the function doesn't take in any input. So when you call it, you don't need to take any input. That's basically that's it. So we are going to write a function. You see, write a function to welcome a user to C programming. So your function should ask the person the name, perhaps. So, but because we haven't gotten to string, you don't have to take the name of the user. You can ask the user to maybe enter first letter of first name, first letter of second name. Then you can display maybe LOGH, welcome to C programming. Or you can do this simple one where we have just display welcome to C programming. Okay, then the second one says write a function which takes a number and returns the square root of that number. Like I explained earlier, square is just the multiplication of the number by itself. So in the argument, which is the input, so you use the one you multiply by itself twice, and you return the value. Okay, so here we have double square. Okay, so we need a square. Okay, did I say square root? No, I mean square. Square root is not multiplication by itself twice. No, that's a square. So the square of a number is the multiplication of the number by itself. So you specify the data type, the name of the function, then the input of the function. So the input, you need to specify the data type of the input. Then you return the same data type. So here is return number times number. So we say multiplication is times. So once we do that, so anytime you call, it will do the square of that number, then it will return the result. Let's say this somewhere and display it on the screen. So the same addition, you just add the two numbers, then return the value. Then double difference, you subtract and return the value. Then product is multiplication, so you multiply, return the value. So this is the area of circle. So area of circle, we have the data type is double. Then because when we calculate it will be in the double of fraction, so the data type is supposed to be double. Then the name of the function is area of circle. Then this is our argument of our input. So it says our input is supposed to be double, of the type double. Then it returns the multiplication of this. So we have pi times radius times radius will give us the area of circle. Okay. Now remember, if you are coding and you are doing it this way, if you define the pi, then you have to define it with a value, just like we did last week. So you first of all define the pi before you use it, and that you can add, you put the value of pi inside. So then we have the circumference of a circle. So we have this function for it. Now function prototype. Now you need a function prototype so that when the program, the compiler starts to create the binaries of that program, when it does it, it's supposed to reserve a space for that function as well. So if the function is going to return an integer value, it needs to reserve a space for that. It's going to return double, it needs to reserve a space for that. So we need a function prototype so that before we call the function, it will indicate that this function is of this type, so reserve that space for it. So when the function is being called, the space has already been reserved, so that after the manipulation, we can either store it over there or we can display it. So basically that's it. So we have this. So the prototype, it doesn't have the implementation of the function. So all the functions have just the front part before the curly brackets. So it's an unimplemented methods or functions. So it ends over here. So you just then the data type is supposed to have the name of the function and the argument. So if there are more than one argument, then argument. So you put the data type of your argument. You don't specify the variable name of your argument. Even though when you do it, you don't get error. There's no need for that. You only need the return data type, the name of your function, then the argument it takes. So this is to reserve a space before even the function is being called, so that you have a space reserved for that task you want to perform. So this is an example of calling a function. So to call a function, you mention the name of your function. So the name of your function comes first. Then in the bracket, you specify your input. So each function has its own input or argument. So you need to know, if you wrote it, then you need to know how many arguments it takes and the data type of those arguments. So you can pass those values to the function when you call it. So in the square function that we wrote, if you want to find the square of a number and put it in this variable, you just have sq is equal to, so it will call this function, implement the code, and the code says multiply whatever input you put here twice or by itself. So here we have the number, here the number is 2, so you have 2 times 2, then the result will be 4. Then so this will return 4. So therefore then it will be assigned to your sq variable. Okay, so it says create a project and name it week 3 exercise 2. Write a function prototype for the example functions above. Implement a function and call the functions in the int main function. So in the int main, so you implement all these functions. We said we have our placeholders over here. So in your placeholder, accept the prototype. So you declare your prototypes over here. We say prototypes are unimplemented functions. So just the data type of your function, the name of your function, then the argument data types. So if there is no argument, if there is no input, you just put it empty. So then semicolon. But if there are input, you indicate the data types of your input values. Then you end all of them by semicolon. Then you can write your function. Your functions, you write them below your int main function. So you write it below your int main function. So this is the closing end of your int main. So you write it below here. So you can write all the functions and follow the examples we have done. So we follow the examples we have done. So in the examples, we have the data type. Now the data type, if it doesn't return anything, is called void. So void means that it doesn't return anything. So if, for example, you're writing a function to do something that doesn't return a value, you have to call it void. So that one, in the void, you don't have anything called return. Okay, so for example, welcome. So welcome, we are just displaying information on the screen. So we don't need any other destination. The data type is going to be void. So we just call the function there and write whatever you want to write over there. Okay. So let's see. Assignment say write a program that takes the x1, y1, x2, y2 of 2 points and calculate the distance between the 2 points. So this is a formula for the distance. So we have the square root. So you know the function, the written function to call. You need to call the sqrt function. But before that, you need to include your math.h in that file. Then you also need the square. So for the square, you need to use a POW. So this will be the base. So in the POW function, this will be the base, and this will be the power. So in the PO function, we said the first one is the base, and the second one is the power. Okay. So here we have the base over here. So in this one, the subtraction between the x and the y, and for the x, the subtraction between the x, then our power is 2. So that's how you do it. Okay. So that's it for this week. So I'm going to do code this one. Even though you can copy and paste, I want to code so that you can see it when I'm coding. So once I'm done, then that's it for the week. So you try to code different functions as well. So like the code I asked you to write to calculate the force of a body. You can write a function to calculate the force of the body. You can write a function to calculate the kinetic energy of a body. You can write a function to calculate the potential energy of a body, and so on. Okay, so that one is your personal project. But I'm going to do this for you so that we can have a feel of it. So now I'm going to clean this one. Okay. Okay. So at the top of your int main method is where you declare your prototype, function prototype. So we say welcome. So in the welcome, we don't ask. So if I want to modify this one, so I'm going to ask the person to enter the first letter of first name, then second letter of the first letter of the second name. Then I'm going to display if the first letter is G and the last name, the first letter is A. I'm going to display G.A. Welcome to C programming. Okay. So that one, so I'm not going to return anything. So I'll call the method void. So I have my method void. Okay, so void welcome. Okay, so welcome. So that one is empty. It doesn't take any input. So here is going to be empty. So if the input doesn't, if your function doesn't take any input, it's just going to be an empty bracket over there. Now, so we said a return type. Here it doesn't have anything to return. So if the function doesn't return anything, we call it void. Then we give the function a name. It follows the naming. Then we have our arguments. If it takes something, you put the data types of the things it takes, of the input it takes. But this doesn't take in any input. Okay. So this is a prototype, function prototype, unimplemented function. So over here below your last curly brackets of your function, you can implement your function there. So here I can have void welcome. Okay. So here I'm going to modify I'm going to write different one than what is on the course content. So so that I can just have some varieties. So here I'm going to ask the person to enter the first letter of first name, then the first letter of last name, then I'll grade the person. So here I'm going to declare value called char f and then ln. Okay, so I print f. I ask the person to enter. So enter first letter of first name. Okay, so that is for the display. Now I need to get the value, so I use the stamp f. So the placeholder for character is C. Then we have the end for the memory. Then our fn is the name of our memory of the memory we want to save the first letter of first name there. So that's it. Then we can copy and paste this one for the last name. Okay, so here we have enter first letter of last name. Okay, last name. Okay, then that one too, the placeholder is percentage %C. Okay, so this will get it, store it on a memory by name fn. Then this will get it, store it by memory by ln. Okay, so now I can greet the person because I have the first letter of first name and first letter of last name. So I can write printf. Okay. Okay, so in the printf, hello. Okay, so in the hello we have our placeholder C dot placeholder C. Then welcome to C programming. Okay, so we need to indicate the first placeholder what is going to replace it, and our second placeholder what is going to replace it. Okay, so our first placeholder will the first C will be replaced by it. Now our second placeholder, this one is going to replace it. Okay, so now you've written your function. Now you need to call your function. So like we said, if the function will return a value, you can assign that value to another you can create a memory space and assign the result of that function there. But if it doesn't return a value, you can simply call that function. So here our welcome doesn't return any value, so I'm going to just call it in our int main. So calling a function is always in the int main because that's where the function starts to run from. So now I'm going to run this and let's see how it shows. It says printf, I left it. Okay. How come I left it? Why stop? Okay. Okay, so my first letter is J. These have us. So J, my last letter. Hello J, welcome to C programming. Enter first letter of last name. The jump is jumping. It is jumping the ln, so let's repeat it. I don't know why it's jumping. Let's repeat it. So when you jump, it will go to the next one still. Jean A. Okay, so hello Jean A, welcome to C programming. Okay, so sometimes if your computer is skipping some of your code, you can repeat the code so that once it's skipped, it goes to where it's supposed to go again. So that is it for the welcome. So I'm going to do what next? The square one. Then you can do the code is already there, so you can try them. But before you watch the code, please do it before you make reference to the code. Okay, so remember the defined one is we lead it in week 1, or I think one of the weeks, whether week 1 or 2, how to define a constant. So this defines a constant pi. So everywhere the pi in capital has been used, it will be replaced by 3.142. So that's why we declare a constant. Okay, so when you are doing that one, you can pay much more attention to it. So I'm going to do that of the square, then the rest you can do them by yourself. If you have any question, you just post it in the comment, then I can reply. So let's do the square. So the square, write the function prototype. So the square, if the function, if we call the square function, we want it to return the square of the number we pass. The number we will pass to the function is what we call the argument or the input. So the number we will pass, which is the argument, we want it to multiply by itself, and it's going to return the value. Okay, so since I want the square to work for both double and int, I will call it a double so that I can enter an integer value at the same time I can enter a double. So I'll have double square. Okay, now you indicate the data type you take. So like I said, I'm going to pass in double because double works for both int and the double itself. So I'll call it double. So this is the function prototype. Okay, so the function prototype indicate that, oh, is there a space, because I have a function which is of the type double, then it takes in a double, so you let it implement the code that you write and return its value. Okay, so that's it. So we write our function here. So we have double square, and we have double you can call it a. Okay, so here all that you need to do is to return a times a. So return a times a. Okay, so return a times a. We pass in our float value, then we multiply by itself twice. So a to be a times 8. Now let's call it. So we can have another double. So double, let's say C. Okay, so we can ask a user to enter a number. So this will be the result. Okay, we call it square, escape. Then the value we get from the user, we can call it number. Okay, so now we can print the user. We can print so that to ask the user to enter a number. So printf enter a number. Okay, then we get the number from the user. So scanf percentage in the quotation percentage LF, and the placeholder is print. The placeholder is number. If I remember, it means the end. Means the end for address, to indicate that the address of that variable. So that's it. So now in the square, this square, we are going to put the square of this number inside. So we write sq is equal to this assignment. We are assigning what we put on the right hand side into what we have at the left hand side. So we have square, so we've called the square function. So in the square function it takes the number. Okay, so that's it for the number. Okay, so that's the square of that number. So if we want to print, then we have printf. Okay, then we have percentage in quotation. Why do I always forget? Percentage LF. So this one will be square. Okay, the square of, let's say square of, okay, this okay, then the value will be LF. Okay, so now the first one is our number, then SQ. Okay, it's not our number, so that will be for the placeholder. Okay, so I go over, then you can do the rest and we call it a day. So we declare two variables, number and SQ. The SQ will store our SQ, the square of the number we are calculating. So the number we are calculating, it will store the square of it. Then the number we want to get from the user, it will go over here. So we give instruction printf enter a number. We use a scanf to get the number. Remember it's double, so the placeholder is going to be LF. Then we have the end number. Then now we call our square function. We call function by their name. So our square function, which is over here. Then the square function, we pass in our number here. So whatever number you put, then it finds the square of that. So you use a placeholder to show which ones will be replaced by what and what variable names will replace them. Okay, so I think that is it. So let me run and see if I don't get error. Okay, I'm getting error. Square. Okay. What is it saying? Error SQ. What SQ? Oh, did I say SQ? I think I was coding. Okay. It's the SQ, not the SQL. Okay. What? Okay. I left the semicolon. Okay. Okay. There we go. Okay, so enter first letter of first name. Godwin. Then A. So Havas, you understand? Okay, so I forgot to give a slash to our display. We didn't have the slash for display, so it's continued from the same line. So we can put our new line over here. Okay, so it started new line over here. So let's see. Okay, so G Jimmy A. Okay, so enter a number. Okay, so square of 4 is 16. Okay, so this one too, you need to separate it by a new line, so it moves to a new line. Okay, let me test it for the last time. We call it a day. So enter a number. First is Jane, second is A. Then welcome Jane, welcome to C program AL, welcome. Okay, Jane. Then August. Okay, enter now to 34. So square of 34 is this. Okay, so that's it for today. So you try to do the other ones. Don't look at them, even though I've solved them, please don't look at them. And the places where we assign the value, please take the values from the user. So all the places where I assign the value in them in the code, and take all those values from the user and code. If you have any problem, you just contact me so we can discuss about it. But thank you very much for enjoying the course. But I promise to do the pi one, so you let me do the pi one. So the pi, you need to first of all define the keyword pi. So you need to first of all define the keyword pi. So anytime you want to use a pi, you need to define it. So now I've defined it. So now if I want to call the function area of a circle, so if I want to return the area of a circle, it's going to be double. So have double area of circle. Okay, now it takes in the radius, so we have just double because the radius is supposed to be double. So that's it. So area is pi r square. So we can even call our square directly. We already have our pi value. Okay, so function. So we said the area is double. So double area of circle. It takes in double, let's say A or R for radius. Okay. Now we return pi r square. So pi, we declare our pi already. We define it. Our r is the r1 here. We say square is times itself. So r. Okay. So that is it. So pi r square. So pi times r. Now we can call it in our code. So we can say enter the radius. So double radius. So we can have radius to double. So radius. Okay. Then we can give the instruction to enter the radius and get it from the user. So enter radius. Enter radius. Then the person where we want to save the distance here is, we call it radius. Okay, so enter a radius, then scanf, we put it on the memory we've called radius. So now we can call one also area, which will calculate the area. Okay, so we can have A is equal to area of circle, which takes in the radius we've gotten from the user. Okay, now we can display the result of our set area of the circle. So printf. Okay, so the area of a circle of radius. Okay, so the radius is with placeholder of double. So LF. Okay, for placeholders we even use F. We don't put LF, we say the standard. Okay. Okay, so the area of a circle of radius, then we put the radius there. Then we put the area there. So our first placeholder is radius. So we have radius. Our second is area of a circle, which is stated to be. Okay. So that's it. So area of the circle. The area of the circle. Remember the pi. The pi has been defined and the value has been given to it. So 3.142. So here it's going to be 3.142 times the radius the user enters times that same radius the user enters. Okay, so let's run this and get a syntax error or not. Okay, so enter. Oh, avars. I want to keep my history. You are trying to say a virus, but next time I will turn you off this code. So enter first letter of first name G. Enter first letter of last name A. So enter a number. So a number can be 3.5. Okay. So radius. So enter the radius 4. Okay. So the area of a circle of radius 4 is 50.6. So this place too, you can start on a new line. So where you say enter a radius, you can start from a new line. So enter a radius, you can start from a new line like this. You can start from a new line. Then the circle to the area of a circle, so you can start from a new line. Okay, so we build again. So enter first letter of first name J. Enter a number. Enter a number. Then a number 5. Radius. Enter a radius. Radius times 6. Okay, so the area of a circle of radius is 6.86. Okay, so that's it. So thank you very much for taking part for taking this week's C programming course. So I believe you'll be able to at least acquire some knowledge. So remember, functions are very important to a programmer because you write your own functions and you'll be using functions that are already built for you. So you have to know the name of the function and the type of argument or the type of input to pass to those functions. So we say functions as data type. If the function doesn't return anything, the data type is going to be void. And the function has a name. The name of the function is similar to the way we name the function, similar to the way we name variables. Now, the function also have arguments. So in the argument is the input to pass to the functions. So you have to specify the data types of all the arguments. Then in your block of code in the function, you implement the function. Now in C, we have function protocol. In other programming languages, we don't have prototype. But in C, we have what we call prototype. So the prototype is to help the compiler to reserve space on the name before the function is even being called, so that it knows that there will be a function which will be declared alongside at the bottom or this. Like I explained that the code runs from line 1, line 2, line 3, and so on. So you need it to write the prototype, so that the prototype is just the skeleton of your function, your unimplemented function. So it's just the data type, the name of your function, then brackets, then the type of data your function argument takes. So then you end with a semicolon. Now to define a constant, we use this statement, the hashtag define, then pi. So you give the constant a name, then the value of it. So anytime you use pi or any other constant you have defined, you see that that's the value, then it will fetch it and use it in your code. Okay, but thank you very much. I think that's all. So that's your assignment as I've talked about it. So you could, if you have an issue, you can just post your comment over here, and I'm here to assist. So I will answer you, and if any of the students can also answer you, that can also be done. Okay, so thank you very much and enjoy the rest of your day. Bye.